Now let's see this. Consider an array having 100 elements. Consider an array has 100 elements and each element occupies 4 words. A 32-bit word cache is used and is divided into a block of 8 words. Now what is the hit rate of this? This program is given. Now just like in the previous example, the cache is same. The cache is going to have 4 words, or let's say 4 blocks, 1 2 3 4 blocks, and each block is capable of holding 2 elements of array A. Okay, now which 2 elements will be present there? That depends on how the elements are stored in the memory. Since it is a 2-dimensional array, there are 2 ways we can store the elements in the memory. So one is in the row major order and other is in the column major order. In row major order, how we store the elements is we are going to store row by row, which means we are going to take the first row. First row is going to contain 0 0 0 1 0 2 0 3 so on, right? This is the order in which you are going to store in the row major order. And in the column major order, how we are going to store the elements is, see, this is one element, this is one element, that is how I am storing it, right? So in column major order, how I store is, I'll store the entire column first. So the first column is going to contain 0 0, right, and then 1 0. So what I mean to say is, if you want to look at it in a diagram, it will be clear. So let's say the array, in the conceptual view of the array is 0 0 0 1 0 2, this is 0th row, right, 0 3 so on, 0 9, all the 10 elements are like this. And what about this one, 1 0 1 1 1 2 1 3 so on, 1 9, right? And what about this one? This column is going to be 2 0 3 0 so on, 9 0, right? And it is going to be 9 1 9 2 so on, 9 9. So this is how you can conceptually look at the array, 10 by 10 array. Now if you are going to save it row by row in row major order, then this entire row will be present here, and after this the next row will be present, got it? And if you are going to save it in the column major order, the entire column will be saved first and then next column, which means 0 0 is there, after that 1 0, after that 2 0, after that 3 0, so on, like this, right? Now nothing is given there, so by default you can assume a row major order and go ahead. What I'll try to do is I'll explain you both the cases. What would have happened if the question has been mentioned as row major order and if the question would have been mentioned as column major order. If nothing is given, go with row major order. Okay, fine. Now by taking row major order, if you are going to ask for 0 0, now what do we get inside our one block is, see here clearly cache block is able to hold 2 words or 2 elements. Now if you get one element also, the adjacent element will come into the main block, cache block, and that is going to give us an advantage in terms of the hit rate if we are going to get the element that we want next. So in case of row major order, what do we get? With 0 0 we get 0 1, with 0 2 we get 0 3, right? With 0 4 we get 0 5. Now keep this in mind, and now let's try to analyze this code. So first thing is, they are going to get one element and they are going to access the element 2 times. One is for reading and one is for writing. Now which element is going to be asked first? For I equal to 0, j equal to 0, which means 0 0 is going to be asked. Now under the assumption that we are going to operate in row major order, whenever I ask for 0 0, what do I get with 0 0? With 0 0 I am also going to get 0 1, right? And we know that 0 0 is going to be accessed 2 times, isn't it? So first time is for reading and the second time is for writing. This is how you are going to access it, reading and then writing, okay? And after this we are going to get 0 1 and then 0 1. So in this order, if you follow it, I is going to be 0 and j is going to be 1. Therefore in this order, this is the sequence in which you are going to refer. So you will first ask for 0 0 for reading, and then ask for 0 0 for writing, and then ask for 0 1 for reading, and then ask for 0 1 for writing. Under the assumption that the array is stored in row major order, you will be getting 0 1 and 0 0 and 0 1 at once into our cache. Got it? Therefore, for one miss, you will be able to hit this as well as hit this, when in case if you are going to use row major order. Got it? And now you can write all those 100 numbers into 50 pairs, and in every pair 50 pairs are there. In every pair we are going to have one miss, right? So the total number of misses is going to be this much, and the total number of hits is going to be out of 50 pairs 4, right? So why? Because at any time I can hold only 8 elements, and so once it is full, again you have to get the same one. There is no concept that the existing numbers is going to save us some hits. There is no concept that way, because our cache is very small compared to the array size. Therefore you have to anyway change all the elements, right? So now if you see this is the total number of misses and this is the total number of hits. And what about the total number of references? The total number of hits is 3, right? For every pair it is 3, and the total number of references is this. Now what is the hit rate? The hit rate is going to be total hits given by total references, which is nothing but 3 by 4 into 100, right? Into 100, that is hit rate or hit ratio. Okay, now this is what is for row major order. What about column major order? In column major order, with 0 0 you are going to get 1 0, which means in our cache, if you have 0 0, if you try to get it, with that you are going to get 1 0, but look at the way you are accessing it. So you will be asking for 0 0 for reading and 0 0 for writing, and after that we want 0 1 for reading and we want 0 1 for writing according to this code. But what is present in our cache? 1 0, which means this one will be a miss and this one will be a hit, and anyway these two are not required, right? See, okay, whatever is present here are not required, and next time when you try to get 0 1, again this one will be a fresh miss, and since it is already brought, this one will be a hit, right? Therefore in case of column major ordering, even if you couple them all like this based on the requests, based on the sequence, the reference sequence, if you couple them into, if you try to write them as if it is like this, for every pair, so how many pairs you are going to get? 50 pairs. For every pairs you are going to get 2 misses, total miss is going to be 2, and for every pair you are going to get 2 hits, and the total differences is going to be 50 into 4. Are you getting this? Why did this happen? Because even though the way in which you refer is 0 0 0 0 and then 0 1 0 1 and then 0 2 0 2 and then 0 3 0 3, whenever you are getting 0 0, along with that we are not going to get 0 1 into our cache, we are getting 1 0, isn't it? And next time when you want 0 1, so even if you try to get 0 1, what do you get is, in column major order you get 1 1 with this, right? Therefore again it is a miss, and next time is whenever you want 0 2, the next one is 0 3, but if you try to get it, what you are going to get as the next one in the cache block is 1 2. Got it? So because of which only one hit and one miss will be there. So first one will be miss, next one will be hit, next one will be miss, and again next one will be hit. Like that you are going to get it, right? Therefore the hit rate in this case, in case of column major order, is the hit rate is going to be the total number of hits, which is 50 into 2 divided by total number of references is 50 into 4 into 100, which means 50%, right? Now in case if you want to improve it, let us say column major order is used and you know that column major order is being used, then you clearly know that with 0 0, 1 0 is going to come into our cache. Now if you want to take advantage of that, and if you want to increase the hit rate, then after accessing 0 0, don't access 0 1, you try to access 1 0. So how is it possible? By interchanging these two, right? Don't take aij, take abi. If you write aji, if you interchange this, then after 0 0, the one you will try to access will be 1 0, and 1 0 will already be present in our cache. That way you can improve the hit rate. Got it? Okay. Now even if the column major order is used, in case if the size of the cache would have been bigger, then we might be able to reuse it again. For example, what I mean to say is, in column measure order, whenever you are trying to get 0 0, along with that you will be getting 1 0, isn't it? And whenever I try to get next access is 0 1, along with that I will be getting 1 1, right? Therefore, if you have to use 1 0 again, by the time we access 1 0 next time or later, if this block is still present in our cache, then we will be able to increase the hits. Are you getting this? Whenever there is a miss for 0 0, I will be getting along with 0 0 1 0 as well. Now if this 1 0 is going to stay in our cache till we access 1 0 next time, then it is going to increase the hit rate. How is it possible? If the cache block size is going to be big, if the cache size is going to be big in such a way that it is able to hold 10 blocks, then let's see what happens. Now this block will be saved, this block will be saved, this block will be saved, all these blocks will be saved, right? So whenever you access 0 0, only for one miss you are going to get these two elements, and for this one, for one miss you are going to get these two elements, and again like this, and next time by the time you come here, this one will already be present in the cache. Got it? Therefore, depending on the cache size and the algorithm you are using, the answer is going to change. So in case if the cache size is only going to be 4 blocks, then whatever we did is right. In case if we increase the cache block size, I mean the entire cache size, then the number of blocks will be more, and whatever data you have prefetched will be useful later. At that point we can increase the hits. I hope you are getting what I am trying to say. If you are trying to read and write here, for one miss you are going to have one miss and one hit for this one, and similarly one hit and one miss for this one, one hit and one miss for this one, and till this point you are going to have one hit and one miss, right? And if this data is already present in the cache, by the time you try to access this element, then reading and writing this element both will be hits. Therefore, for this pair, for one miss you are going to get 3 hits. Again, this is as good as the row measure order, right? Therefore, if you increase the size of the cache, then also the answer is going to get affected. Got it? Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.